Welcome to another video and episode on my Raspberry Pi 1 running Raspbian Linux and connected with a band cable to a breadboard with electronics serially to a serial terminal, networking for virtual network computing, and with a camera I currently don't use. With the band cable I am connected to this breadboard, which is being used for experiments with an analog to digital converter, which is this one. And there have been some problems lately, and last time it turned out that it was probably a software error, although some things really didn't work physically. So how do things work? Well, compared to last time, I have removed most of the connections to the converter. The only thing that is now working is this LDR, light dependent resistor. Software pulse modulation for the for two LEDs, this one and this one actually. And when this still works, I am going to expand it for the second port on the ADC with this fischertechnik LDR. So then I should have two separate values of that, but I need to wire it and then see that the program still works or works at all. Now this ADC is using the SPI protocol, and also to check these probes to the oscilloscope. And I also found out that the readings that I got from the oscilloscope weren't quite accurate because of the timing set in the program, and that has to be kind of equal. So when the program is set to 1 second, I better set the time base on the oscilloscope to 1 second, and then it turned out that it was actually accurate as far as I could determine. Anyway, let's see how the program now works. And using the VNC desktop, I see that the LDR is responding. Putting my finger on it to shield from the light, I get very low values, and remove my finger immediately gives high values. So that is working. And also on the oscilloscope I get readings. So when I cover it, then I see no spikes on the data, and when I remove my finger, then I see spikes returning. So that works as well. And this wiring PI controlled LEDs work, but they did before. So with this introduction I continue with the whole setup, and I should be able to hook up this one using these wires and potmeter. I did use that before, but I decided to remove them all to get at least a working starting environment. So now I'm going to build it up, and I may end up with a little spatial problem. Although there's enough breadboard, but the ADC is here. And it's a little bit, well, spatial done. So I hope I don't have to rewire all this. Anyway, let's continue wiring up this one. So first up is this, pot meter, which is 10K maximum. It is set to the maximal value, and I can only put it right now right here. And hoping it makes contact. Next thing up is the wiring. So how to wire it up? Well, I decide to put this one in line here, and the other one, the other wire, can use the ground for this one. Ground is ground. So I'll put this one right here. Should be alright. Although it's, I'm not very happy with this one, but alright. Next piece of wiring. Now this should not be too hard, but it has to go from here to the second port. And let's put it right there. Alright. So this is now wired up. Should be. And nothing else is actually needed, provided that this one is actually making contact nicely. Well, it should be, because I used it before. And the only thing needed is now programming. So first let me, without programming, see if this works as it just did. And there is no problem. So in wiring it's okay. And let's see on the oscilloscope. And on the oscilloscope I may have a little problem, because I'm only wiring up one thing at a time. So that is going to be new, how signals are going to be read there. Anyway, this works. Readings from this LDR work. So let's see how this one is going to work from the resistor to port 2. Actually 0 to 7, so it's port 1. Anyway, some programming to do. Alright, continuing. The program works, that is no doubt. I will show you it does. And you see here the spikes on the oscilloscope. So that's data like clock, data, CS bar, and data in, which shows not much, but that's no problem. This is the second one. I already have drawn it here, but without the connection to the port, and the C will be done as well again. Alright. Second LDR channel is 1. Then, more importantly, how do I define it? Well, according to the information I found last time, I have to make an SPI2, and then which is then also SPI dev, and then open 1. Is that actually going to work? And that is a very good problem, very good question. So here I have LDR value so I make this 1, and then this is channel 1, because this is, oh, I have here channel 2. Well, you know what, I keep this, I will keep it channel 2. Then I have to print it, and that's about it. So when it is really working, I should get 2 different values now. The other thing is, of course, if it doesn't work, what's the culprit? Is it the oscilloscope? Is it whatever? So unknown grounds from now on. The wiring is complete, the wiring is okay. Let's see. Does it work at all? Oh, look at this. It does work. This is LDR2. This is LDR2 again, without, oh, this worked nicely. And this is a bit strange because I actually cover it up, while when I cover this one up, this is 1, its value goes down. And when I uncover it, value goes up, and here it's the other way around. So what if I check? Well, this is a resistor, so it should not matter. But I find this a bit strange. It's analog. It has no plus and minus, which is the whole thing of a resistor like this one and like this one. They have no plus and minus. You can put them in any direction you want. So why is this one now giving a high value and uncovered a low value? That is a very nice question. But on the other hand, I am very happy that it works. Very happy indeed. This means that I can build it on, proceed and see whatever I can do with this LDR. On the other hand, how does this SPI protocol behave? I see high and low values, so I'm covering up. What do I see? Now they are all high. Is that going to work out? Now I see all high spikes in data. I uncover. What will happen to the peaks? A very low one here. Is that true? low, high, high, high. Low, low, high. Let's wait a bit more. Low, low. Okay, so the values are apparently indicated by the peaks. So low and high. Interesting to see if that is correct. Okay, now back to construction. I need another one to connect to the ADC channel 3. Let's see how that works out. So with the LDR I have to keep in mind what the distance is. So I want to use port 3, and I can use it like this, but also in this way. Be careful. This is one. Then, using the same principle for the NTC, I need one wire to be connected to the minus. I will use this wire for it, but I also need to connect this one to here. I will use this small jump wire for it to bridge the gap, literally. And it's a small one. Alright. So now, how shall I bridge this one? Well, I need to bridge here something as well. So first in comes this one. Put in this one for connection to the ground. It's a very tiny wire, actually too tiny, so I'm going to use another very small jump wire for that. It barely wants in. Alright, this wire goes in here. This goes to ground. If I can make it so. Alright, that's one. And then I need to bridge the gap between here and there. And therefore I'm looking for another jump wire to bridge that gap, and that's going to be a challenge. But I'm rapidly going out of flexible jump wires. Let me try this one. One here and one. here. So actually this should be working. And all I have to do now is program it and see if it actually does work with this pot meter set to around 10 kilo ohms. So let's see how that works out. As you can see from the serial terminal, an incident happened, unfortunately. The Raspberry Pi reset itself. It rebooted. So I had to do things exactly the same way. However, let's try to open a third SPI thingy, copying this one here, and now that I know that this works, I can just go on, although this should be then 2. Then I will have to do anti-R channel, anti-C channel, which would be 2. And then here enabling these things. Anti-C channel, is that correct? Yeah, that is correct. Print anti-C value. And yes, that should be all correct. Now, let's find out if that actually is. And here I meet with a problem. No such file directory. Ouch. So I'm using 2. Why am I not using 3? Or should I be using 1.0? There are, after all, 8 ports. Now I found the SPI2 code on the net, and I assumed that this would do the same, but apparently not. Let's find out if 1,0 will work. I assume not, but if I don't try, I'm not. No. Okay. So here I have a problem. And how to solve it. That's another very good one. And it really blocks on this. So I am going to find how this is going to end. I managed to fix things, and I did have to change the code. One thing is that I did not find anything about SPI 3, but I also reasoned that I don't have to use 0, 1. Now I have SPI 1, 2 and 3 all open at 0, 0. And they all function. So let me have a look here at a little bit of nah, that's okay, that's all okay. There's just no line in between here, but as you can see, first LDR is this one, and I put my finger on it and the value drops to 0 or very low. Nah, alright, too high. Now it drops to low again. LDR1 value, and for easy readable I should actually turn it up to, yeah, how much? 2 seconds delay, 3 seconds delay. I can do that. If I change the oscilloscope, then I have 2 and 5 seconds. It will be easier readable, but let's keep it to 1 second. Then the second one still works. Exactly the other way around. Or does it? Well, yes, because now 2 is covered and gives a value as low as LDR1. And now it drops again. So covering up 1 goes very low, uncovering goes high. And this responds as well. So that works, and the ADC shows very nice values too. If I hold it, then the value changes a bit, not dramatically, but this does show that everything works. They respond very nicely. LDR value is a very high value now, 194. Whoops, mind the components. Very low value for 1, uncovering, and it goes up again. So this shows that things actually do work, and in a somewhat different way than I thought. If I make this one and this one, it works as well, but let me just keep it this way. Another thing is, how does the oscilloscope respond? And here you see already that some values are low to 0 even. So all data is now mixed here. Which is which isn't readable. For this, for the real values, you have to see the screen output. So about that, it is a very successful experiment now. Where to go from here? Well, we'll see. How much can I do much more? Can I use a pot meter to change the value? So a pot meter behind the pot meter and then connect to the ADC. That should give a real value change. Let's see about that next time. For now, I'm glad it keeps working now. both the VNC and the Raspberry Pi. Yeah, once again, thanks for watching. If you like this video, please subscribe to my YouTube channel, give the video a thumbs up, leave a comment, very much appreciated. You can also follow me on Twitter. Retweet, like and leave a comment. You can also follow me on Instagram, like and leave a comment, very much appreciated. Also appreciated is if you donate to keep videos coming to you. You can also become a patron, and then your name will be mentioned either on just on my website or on my website and with my video, depending on what pledge you make. Very much appreciated. And this is going to be continued. Bye bye.